Okay, now let's learn another skill that's very important in chemistry. It's called scientific notation. In science, we deal with some very large numbers. For example, we'll talk about moles later on in chemistry, but 1 mole of a substance would represent this many atoms of a substance. And I always, 1 mole is, if you counted this as the hundreds, the thousands, the millions, the billions, the quadrillion, and see, I don't even, you get such large numbers that you don't even use them all the time. So I don't even know what you call this number, but that's a lot of atoms, a very large amount. So 1 mole equals a very huge number. But also in science, we deal with some very small numbers, like the mass of an electron. An electron is a very small particle, and so you can imagine it has a very small mass. Imagine trying to keep track of all these zeros in a calculator and figuring out what place it's in. It becomes very difficult. And so that's why we use scientific notation in science a lot. So yeah, no, we don't really want to write out all those zeros. You can imagine you'd make a lot of mistakes if we had to write all those zeros. And so we don't. And I'll show you a way that makes it a lot easier. Like this slide says, imagine the difficulty of calculating the mass of 1 mole of electrons. And so an electron has the mass of that. If we had 1 mole, we would times it by the amount of 1 mole. And could you imagine doing the multiplication longhand with this type of problem? I mean, it'd just be impossible. And so let's learn scientific notation. It's a skill that's essential in chemistry and basically all sciences. Scientific notation, if you're following along in the guided notes, you would write this down, is a method of representing very large or small numbers in this form: m times 10 to the n. M in this case, so this m right here, this m right here is called a coefficient, and it's always a number between 1 and 10. It has to be a number between 1 and 10. The n up here, so this n is called an exponent, and it can be either a positive or a negative number. So the largest diamond in the world is called the Hope Diamond. I think it's one of the larger ones. I don't know if it's still the largest, but one of the largest diamonds in the world is called the Hope Diamond. The number of carbon atoms in the Hope Diamond is 4.6 times 10 to the 23rd. 4.6 would be the coefficient, and 23 in this example would be the exponent. Let's kind of contrast between standard form and scientific notation just to be clear on maybe help you see what scientific notation does for us. Standard form is when a number is written all the way out. So for example, in this example, we got a number called a number that is 600,000. So 600,000, that's written all the way out. Scientific notation is when a number is written in the form of m times 10 to the n. So if we were to take this number in standard form and convert it to scientific notation, this is what it would look like: 6.0 times 10 to the 5th. And so it's a little bit easier for us to use large numbers in scientific notation. So we will now learn how to go from standard form, so this number, and change it into scientific notation. Let's take this number for example, 2,500,000,000. Let's take that number in standard, it's written in standard form obviously right now, and convert that to scientific notation. So there's a few steps. Step number 1 is to insert an understood decimal point. Step 2 is to decide where the decimal must end up so that one number is to its left. And step 3 will count how many places you bounce the decimal point, and then step 4 will rewrite it in this form, m times 10 to the n. And so let's do that now. An understood decimal point for this number would be right here. As you can see, that decimal came in at the very end of the number. That's where an understood decimal would be placed. Okay, so we've done step number 1, so we can check that one off. Step 2 is to decide where the decimal must end up so that one number is to its left. And so if you look here, so that the decimal needs to end up right here. So there's one number to its left. Okay, so step 2 is done. Step 3 is to count how many places you bounce the decimal place. So we will have to bounce that decimal 1, 2, 3, 4, 5, 6, 7, 8, 9 times in order for it to for the decimal place to end up where we want it. Okay, and that becomes very important. We need to remember how many times we bounce that decimal. Now step 4 is to rewrite this in the form of m times 10 to the n. Our m in this case, let me switch colors. Our m in this case will be 2.5 because our decimal place ended up right there, times 10. The n is how many times you bounce that decimal or move that decimal. So we moved it 9 times. And so this is how you would write that number in scientific notation. And it takes care of all these zeros for us. This exponent tells us how many times we move the decimal. So very useful. Anyway, let's try some more. Okay, let's take this number in standard form. Now it's a small number. It's smaller than 1. Very, very small number. Let's switch it to scientific notation. So step 2, decide where the decimal place must end up. And so step 3, count how many places you bounce the decimal and rewrite in the form m times 10 to the n. Okay. So again, we want there to be one number to the left. So that decimal, we want it to be right there. Now we need to count how many places you bounce the decimal. So 1, 2, 3, 4, 5 times. We had to bounce that decimal 5 times. So now let's rewrite it in the form m times 10 to the n. So our m, our coefficient in this case, is going to be 5.79. And then we're going to go times 10. And then the n is how many times you bounced it. We bounced it 5 times, but we went to the right. And so that's going to change the sign of our exponent. It's going to be a -5, not positive, because we bounced it to the right. So numbers that are smaller than 1 will have a negative exponent. So if they're very small numbers, they're going to have a negative exponent here. Okay. Okay, so a recap on scientific notation. You count the number of places the decimal point must be moved to give the coefficient a number between 1 and 10. The number of places you move the decimal equals the value of the exponent. The exponent is positive when the decimal moves to the left and negative when the decimal moves to the right. So 800 in scientific notation would be 8.0 times 10 to the second. 0.0000343 in scientific notation would be 3.43 times 10 to the -5. Again, let's note that this exponent on this exponent on this number is positive 2. That number is bigger than 1. It's a large number. It's got a positive exponent. While this number being less than 1, so it's a very small number, has a negative exponent. So that's always important to kind of remember. Now we're gonna go through a number of practice problems here to get this skill down, to be able to understand scientific notation. All right, this first practice problem, number 10, it says the diameter of the sun is, let's see, that would be 1,392,000 kilometers. Write the diameter of the sun in scientific notation. Okay, so let's look at this. Let's see if red will show up. We have an understood decimal right here. Okay, we want to move that decimal so that there's one number to the left. So that decimal needs to move over to here. Now let's count how many times we need to move that decimal. So 1, 2, 3, 4, 5, 6. We need to move that decimal place 6 times. And so our coefficient in this case will be 1.392. We don't need to write all these zeros because they'll be taken care of for us with the exponent. And we're going to say times 10, and then the exponent is how many times we move that decimal. so we moved it 6 times. And it's a large number, it's bigger than 1, so we have a positive exponent. And so that would be how you write this number in scientific notation. Let's see if we got it right. The answer, yep, perfect. Okay, so that's practice problem number 10. Let's do some more. Try and get the hang of this. Practice problem 11. It says the density of the sun's lower atmosphere is 0.000028 grams per centimeter cubed. Write this number in scientific notation. Okay, now you're going to notice this number is a small number. It's smaller than 1. But again, we want the decimal. I kind of like red. Let's go back to red. We're going to want the decimal so that there's one number to its left. That means the decimal's got to end up right here. So let's see how many times we have to bump that decimal. So 1, 2, 3, 4, 5, 6, 7, 8. So we had to bump that decimal 8 times. And that's going to be important to remember. So let's write it in scientific notation now. So our coefficient is going to be 2.8 times 10. In this case, we moved it 8 times, but we moved it to the right, so that means it's got to be a negative 8. Was it 8? Let me count again. 1, 2, 3, 4, 5, 6, 7, and 8. Yeah, and so it's a small number. That means the exponent is going to be negative if we move that decimal to the right. Okay, and so that will be our number in scientific notation. Let's see if we got that right. And we did. Great. Okay, practice problem number 12. We're going to express this number in scientific notation. So the number is 700. Again, it has an understood decimal place right here. So I always like to write where the understood decimal is. We want it so that there's one number to the left. So we want that decimal to be in between right here. So we're going to have to bump that decimal 1, 2 times. So let's rewrite it. The exponent is 7.0 times 10, and we moved it twice. We moved it to the left, so it's going to be positive, and that's a large number, so it's going to be positive. And so there we go. Practice problem number 13. Let's change this number in standard form into scientific notation. So 38,000 has an understood decimal place right here. I like to draw that in. Now we want it so that there's one number to the left. We want that decimal to be right here. So let's count how many times we need to move it. 1, 2, 3, 4. So we moved it 4 times. So our answer will be 3.8 times 10 to the 4, to the 4th power. Okay. And we got it right. Great. Okay, practice problem number 14. Let's write this number in scientific notation. All right, let's go. We want one number to the left of the decimal, so we want that decimal to end up right here. Let's count how many times we need to bump it. 1, 2, 3 times. Now again, we went to the right this time, so our exponent is going to be negative. But our coefficient is going to be 5.4, and our exponent is going to be 1, 2, 3. We bumped it 3 times to the right, so it's a negative 3. Again, if it's a small number less than 1, it's going to have a negative exponent. Okay, and yes, we got it right. Okay, practice problem number 15. We got a few more. It says express the following number in scientific notation. So this is a large number. Let's see, that would be 685 trillion. Is that right? So thousands, millions. No, it's billion. 685 billion. Let's change that to scientific notation. Again, it has an understood decimal at the end of the number, right here. We want the decimal to go right, so there's one number to its left. So let's count how many times we need to bump it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. I'm going to make note of that. So our number in scientific notation will end up being 6.85 times 10 to the 11th power. Let's see if we got that right. And we did. Awesome. Okay, practice problem number 16. We're going to write this number in scientific notation now. As you'll notice, is a very small number. So let's see how we do this one. Again, the decimal place is right here, but we want it so that there's one number to the left. We're going to count now 1, 2, 3, 4, 5, 6, 7, 8 times. So make note of that, we moved it 8 times. So the number in scientific notation, 7.6 times 10. We moved it 8 times, but we moved it to the right, and it's a small number, so we're going to put a negative in front of this exponent, and -8. And we got it right. So good. Hopefully you guys are getting the hang of this, getting the hang of the scientific notation stuff, because we will be using it all year. So doing good. Let's go to, I put in a few extra practice problems in case you need it. I don't think we'll cover it on the video. We might do it in class. Now let's go to just to the application of this. Using scientific numbers with your calculator. I will show you how to enter scientific numbers into your calculator. We'll do this in class in great detail. But everyone needs to have a scientific calculator. So if you're watching this video at home, grab your scientific calculator and we'll go through it. We're going to do this problem first as an example. Scientific notation, doing calculations in a calculator can be a little tricky because of the orders of operations. We're going to take this number and we're going to times it by this number. It looks like it's a really a complicated calculation, but with our calculator we can make this very easy. And one thing that I'm going to teach you in class is where to find the big E button. So if you look at your scientific calculator, there is, they're all different, so I can't tell you exactly where it is, but there's a button that has a capital E, and a lot of times it's big E, so 2 big E's. That means something very important. That means scientific notation. So this button, big E, I call it the big E button. It means times 10 to the something. So it's a shortcut button. So we'll have to enter in the coefficient, but if you hit the big E, it will automatically write all of this in for you. And it takes care of our order of operations, so you make a lot less errors if you use this button. And so let's practice this one. Let me put this in the calculator. 2.32. I'm going to put the big E button in now. So big E, and then all I have to do is enter 4, and then times 7.47, big E, and now I have to hit a -2. Not the minus subtract button, but the negative sign, and then hit enter. And so my calculator will give me this number, so 1,733.04. Oops. Okay, let me write what that will look like. What I put in my calculator, I put in 2.32, then I hit the big E button, and then I have to hit 4 because you have to put in this exponent by yourself. And then I hit times 7.47, big E, and then you have to hit a -2. And then if you enter it in your calculator this way, you should get this answer. If you're not, please come talk to me. We'll figure this out. Every calculator is a little bit different. I'd show you on mine, but of course you probably don't have the same exact calculator as I do. But if you put it in the calculator this way, you should get this answer. And so we'll spend a lot of time in class going through it because we'll do some calculations like this a lot in chemistry. And so yeah, we did get the answer right. In standard form, it's that which we got. So great. Okay, let's go to practice problem number 17 and do this calculation. I should have moved this. Okay, this -5 is the exponent here, so it really should look like this, -5. And this -4 should be the exponent here. And so, anyway. Okay, let's put it in the calculator. I would put 3.45, hit the big E button, and then you had to put a -5 in, and then let's just hit the addition button, 8.76, big E, and the -4. Now if you put it in your calculator just like that, Let me see if I can get this answer right. 3.45 big E to the negative 5 plus 8.76 big E to the minus 4. My calculator is giving me this answer, so 9.105 e to the minus 4. Again, another way of writing this is 1.105 times 10 to the minus 4. So in scientific notation, that's what you should get. And yes, we are correct. So great. Hopefully you can get that in your calculator. Let's do one more practice problem on this. This one is a division between two numbers in scientific notation. So what I would put in my calculator to get this right is 5.43 big E 5. Then the division button on your calculator, 9.32 big E to the negative 4. If you put that in your calculator, let me see if I can get it right. 5.43 big E to the 5 divided by 9.32 big E to the minus 4. So I'm getting a very large number. Let me write that in scientific notation. Something about 5.826. There's more numbers than that. Times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. Times 10 to the 8th. Hopefully that's what the answer is. And yeah, okay. They rounded the 6, rounded the 2 up to a 3. So same answer here. So hopefully you can get that in your calculator. If you're having trouble with this E button, this big E button, come talk to me. We'll figure it out. So okay, you now know enough to complete the scientific notation worksheet in your student workbook. Remember, if you have any problems, to watch the video again. Sometimes it takes more than just one time to fully understand it. But hopefully that helps. Good luck.